Okay, this video is a review for your test, and this section of the review is focusing on the graphing portion of your test. So we did graphing last class, and I want to do more practice of it. So at the top of the notes, it's got everything listed in one spot of how to find these different things. So the first one is the vertical asymptotes. That's where you're going to set the denominator equal to 0. The horizontal asymptotes, there's actually options, but when we are graphing, I'm only going to give you ones where the degree on the top matches the degree on the bottom. So because of that, because the degree is the same, it is the ratio of the leading coefficients. The x-intercept is found by setting the numerator at the top of the fraction equal to 0. And the y-intercepts, we plug in 0 for x. So it makes those x's go away. We can just focus on the numbers at the end. And that gives us our y-intercept. For the whole, and that's not going to be on every one, you're only going to find it when I leave a blank for you to find it. But you need to factor first and then determine what cancels. Based on what cancels, if it cancels out, that is where you're going to find the whole. So let's take a couple examples of each of these so we can work through these. So let's start with some of the rational graphs. Let's look at the first one. So the vertical asymptote, we're setting the bottom equal to 0. So I have x minus 3 equals 0. And I've said it before, but I'll say it again. I am showing my work on these so you know where I'm getting the numbers. But if you can do this without work, that's even better. So my vertical asymptote will be x equals positive 3. My horizontal asymptote is the ratio of the leading coefficients because the degree is the same. So I have 2 over 1, which is 2. So the first thing I'm going to do is I'm going to have a vertical line at 3. And I'm going to have a horizontal line at positive 2. All right, now that I've got my lines, now I'm going to need to find 4 points, 2 in each section. Remember, there's always 2 sections and they're always opposite diagonals from each other. So the first point I'm going to find is the x-intercept. And that, as we can see from our chart up above, is when the top or the numerator is set equal to 0. So I'm going to have 2x plus 1 equals 0. So I have 2x equals -1, so x is -1/2. And the x-intercept and the y-intercept are always written as an ordered pair. The y-intercept is when x goes away. So if x goes away, we're just left at the numbers at the end, and that gives us that y is -1/3. So the first thing I'm going to do is plot my 2 points. So I have 0, -1/2, and 0, -1/3. About there respectively. And then with the 2 points, I've got an idea now of what the curve will be, and I can make the curve heading towards the asymptote. Now that I have 2 points, I just have 2 more to go, and I can see that my first 2 points are in the bottom left, so I know that the rest of the points are going to have to appear up here in the top right. I can't plug in, if I'm looking at my x's, I can't plug in 3 because that's an asymptote. So I'm going to start 1 over, which would be at 4. So I'm going to find f of 4. So I'm going to plug 4 in everywhere I see an x. So I'm going to have 2 times 4 plus 1 over 4 minus 3. So that's 8 plus 1 over 1, which would be 9 over 1 or 9. Okay, showed a lot of work on that. Wasn't all necessary, but so 4, 9 will be somewhere up here. All right, let's see what happens when I go 1 over and do 5. 2 times 5 is 10, so I have 10 plus 1 over 5 minus 3. So 11 over 2. Again, if you're having trouble graphing that in your calculator, do 11 divided by 2, and you'll get 5.5. So then you know where it is. It's on the 5 between the 6 and the 5. And there is the second part of our graph. Now remember, when you're graphing these, they should be curved. It's like you've got a portion of the circle there. They should not be zigzagged at all, and they need to be approaching the asymptotes, but not actually touching them. On the second one, vertical asymptote, the bottom equals 0. So we get x equals positive 2. Horizontal asymptote, ratio of the leading coefficients. So we get 1 over 1, which is 1. So we have a vertical line at 2, and we have a horizontal line at 1. The x-intercept is when the top equals 0. So I get x is -4, so it's -4, 0. The y-intercept is when we plug in 0 for x, so everything goes away except these last numbers. And when that happens, 4 divided by -2 is -2. All right, so now I'm going to plot my two intercepts. So I have -4, 0 and 0, -2. And now I can see what the curve is, and it's going to go like that. Since those points are in the bottom left, I know that my next points have to be over here somewhere in the top right. I can't plug in 2 because that's an asymptote, so my best place to start is 3. So if I find f of 3, I'm plugging 3 in for an x, so I have 3 plus 4 over 3 minus 2. It's going to give me 7 over 1, which is just 7. And then keep working my way over, find f of 4. So that's 4 plus 4 over 4 minus 2. So that gives me 8 over 2, which is just 4. And here we go. All right, so none of these asked for holes to be found, and none of these could be factors. So we couldn't do that portion of it. But now if we go to the next view, then it changes. Okay, on this one, we need to be able to factor it to be able to find the hole. So if we factor it, the top is going to factor to x plus 3, x plus 4, and the bottom is going to factor to x plus 3, x minus 3. So whatever cancels out, that x plus 3, if we set that part equal to 0, that is where the hole is going to be. But then I want to write my answer as a reduced fraction because this is the function that I'm going to work with moving forward. So to find my vertical asymptote, I'm going to set the bottom equal to 0. So I get x is 3. Your hole and your asymptote can never be the same number. So if they are, somewhere along the line, you've made a mistake. Your horizontal asymptote, ratio of the leading coefficients. So it's 1 over 1, which is just 1. So I'm going to have a vertical line at 3 and a horizontal line at 1. So the x-intercept is when you set the top equal to 0. So I have x plus 4 equals 0, so I get -4, 0. The y-intercept is when you plug in x's and they go away, so I get 0 equals -4 thirds. Again, if you need that as a decimal in your calculator, do 4 divided by 3. So I've got -4, 0, and 0, -1.3. Now, before I draw these in, we got to stop on these. Let's think about where the hole is. The hole is at -3, so it's going to be somewhere along that line. Oh, probably do that a little bit too long. Take 2. It's going to be somewhere along this line. Well, I can see that that's going to occur in that bottom left corner. So when I draw in my asymptote, or not my asymptote, but my curve, I'm going to draw it in. When I get to the -3, I'm going to draw an open circle, and then I'm going to keep on drawing. And there is my curve. Okay, so now I have at least 2 points in the bottom left. So now I'm looking for points up here in the top right. All right, so if I'm looking for those, I can't do 3, so I'm going to start with 4. So f of 4 would be 4 plus 4 over 4 minus 3, which would be 8 over 1. And then if I keep moving over, my next one would be 5. F of 5 would be 5 plus 4 over 5 minus 3. So that's 9 over 2, which is 4.5 if you make it a decimal. And now I've got my graph. All right, let's try this again on the next one. I got to factor the top and the bottom. So this is going to be x minus 5, x plus 3, and this is going to be x plus 3, x plus 1. The x plus 3's cancel. Whatever part cancels out is where my hole is. So my hole is at -3. I'm going to use only the reduced version to figure out where everything else is. So my vertical asymptote is where the bottom equals 0. So I get x equals -1. The horizontal asymptote is the ratio of my leading coefficients. So I get 1 over 1, which is just 1. So I have a vertical line at -1 and a horizontal line at +1. And now I need to plot my points. So the x-intercept is when the top or the numerator equals 0. So I get x is 5. So this is 5, 0. The y-intercept is when x goes away. So it's just the numbers at the end. So it's going to be -5/1, which is just -5. So when I plot my points, I have 5, 0, and 0, -5. Now, before I draw it in, let's think about where that hole is. The hole's at -3. It's not always at -3, just happened to be that way this time. Okay, so that's where the hole is. So it's not going to be in that bottom right corner, so I'm not worried about that. I can just go ahead and draw on my graph. So since my points appeared in the bottom right corner, I know the next group has to be in the top left corner, which would be over here in this section. Okay, so let's see if we can figure it out. I can't do -1 because that's an asymptote. The next one over would be -2. So f of -2 would be -2 minus 5 over -2 plus 1. So that's -7 over -1, which is 7. Point. The next one would be -3, which would be -3 minus 5 over -3 plus 1, which would be -8 over -2, which is just 4. But look, oh, that point is right here. It's on my green line where I'd find the hole. So instead of doing a solid point, I'm going to do an open circle. And then when I graph it, there is my arc. Okay, let's look at these. Now, what we did on the first 4 are rational graphs. What we're doing, the last 2 are inverse. The rational ones have the same shape as the inverse, but the inverse always follow the same pattern. You're not necessarily going to see that with the rational graphs. Some is the same, some is the different, but let's look at these. Now, what I intended to do, and I didn't, was make one of these negative. So let's make this one negative here so you can see both versions of this. So the vertical asymptote is what makes the bottom 0. Nothing new there. So we get x equals -3. The horizontal asymptote is whatever number is at the end. So it's y equals -4. The domain is all real numbers except x cannot equal -3. And the range is all real numbers except y cannot equal -4. So I'm going to have a vertical line at -3 and a horizontal line at -4. And now I'm going to use my pattern. Now, because the top is a +1, +1 is going to be in the top right and the bottom left. Okay, so if I drew a line, my slope would be positive, right? So now use your pattern. Over 1, up 1, over 2, up 1/2, over 1/2, up 2, and there is your arc. Same pattern in the bottom left. Over 1, down 1, over 2, down 1/2, over 1/2, down 2, and there's our arc. Let's try the second one. On the second one, the vertical asymptote is what makes the bottom 0, so that's x equals 1. The horizontal asymptote is the number at the end, so it's y equals 2. So this, I get all real numbers, except x cannot equal 1. And here I get all real numbers, except y cannot equal 2. So when I graph it, I have a vertical line at y equals 1. And I have a horizontal line at y equals 2. But this time, because it's the negative, it's going to be the top left and the bottom right. And if you drew a line, that's negative slope. Okay, so let's see if we can plot them. Over 1, up 1, over 1/2, up 2, over 2, up 1/2. And then over here, over 1, down 1, over 2, down 1/2, over 1/2, down 2. And there is your graph.